Hi, and welcome to the RIP channel. For example 5 of RIP, or row integration by parts, we're going to find an antiderivative of arcsin of x. Row integration by parts is the tabular method for integration by parts, with an emphasis on the rows. Each row represents an integral, and we proceed one row at a time. If you haven't seen an intro to RIP, you might want to pause this video and take a look at the introductory video and then get back to this one. We always start with 4 columns, alternating plus minus signs, functions to differentiate, functions to integrate, and a 4th column representing the integral of the product of the information in a given row. In this case, we're just going to need one iteration of integration by parts, but then we're going to need to do some substitution. Alright, let's see how it works. Start with a plus sign indicating a positive 1. We have to differentiate arcsin, otherwise we would just end up with the original integral, and that leaves a 1 to be integrated. Notice that the top row, once we take the product of 1 times arcsin times 1, gives us the original integrand. So the top row represents the original integral. Apply the procedure by alternating a plus sign to get a minus sign, differentiate arcsin, integrate 1, and then take the product of the negative 1 times 1 over root 1 minus x squared times x, and integrate that product. How do we do this? Well, we should stop and try substitution, right? We could substitute something to replace the 1 minus x squared and hopefully get a replacement that will handle this x in the numerator. So let's try q equals 1 minus x squared. So dq is negative 2x dx, which implies that a half of dq is negative x dx, which is perfect. That means the substitution is going to work out really well. So the negative of the integral of x dx over root 1 minus x squared with the substitution becomes 1/2 of q to the negative 1/2 power. Right, so make sure we've done this carefully. The negative x dx is replaced by 1/2 dq, as indicated here. And of course q is 1 minus x squared. In the denominator with the square root, we could rewrite that as q to the negative 1/2 power. Apply the power rule, add 1 to negative 1/2, get positive 1/2, multiply by 2 instead of dividing by it, and replace the q with 1 minus x squared again, and we get an antiderivative, at least for this integral, of root 1 minus x squared plus c. Now, to get an antiderivative of arcsin, we have to go back to the table. And we get 1 times arcsin, go down a row, multiply by x, and the first term is x arcsin x. The next term is just what we got for this integral, which followed from substitution, and we get plus a square root of 1 minus x squared plus a constant. So don't be confused, this negative didn't disappear, it was absorbed effectively by the substitution. And that's it. So please subscribe, take a look at the playlist, and learn to master integration by parts.